14.3, verified trig identities.
Oh, yeah.
Is this difficult?
It looks difficult.
No!
Yes and no.
Alright.
I will tell you that most of the people in pre-cal said that they thought this was really confusing last year, but when we did it this year, they felt like it was easier.
I just put one.
I almost forgot.
I didn't know what time the clock.
So the first one say to find the values of the other 5 trig functions of theta. This is not English class. Stop talking about the test and focus. Number 6. Sine of theta is equal to negative 7 over 10. Pi is less than theta is less than 3 pi over 2. So these first 2 problems are going to be a little bit of a throwback to stuff we were doing in chapter 13. And then we're going to jump basically into the stuff where we're actually using the trig identities. So to figure out where these things go, if you remember when we had the ones that gave us like a coordinate point and we were plotting those on there, we're doing something similar with this. So we need to look at basically thinking about our unit circle. Where is this theta value? Well, it's between pi and 3 pi over 2. So that means that it's down in quadrant 3. So that means that I'm focused down here. Okay, remember we still are touching the x-axis just like we did before. Theta is always going to be the one closest to the origin. So then I need to look at my sine value or think about what sine means. Well, sine is opposite over hypotenuse. So that means that from here, the opposite value is over here, which is negative 7. Hypotenuse can never be negative. So if you have a negative on basically sine or cosine, you know that that has to be on the like x or y, depending on what it is, obviously. But it can never be on the hypotenuse. So then my hypotenuse here is 10. So I'm solving for all 6 trig functions. Obviously, they've given me one of them. So what do I need to do to find this other side?
7 squared, well, negative 7 squared plus 10 squared equals c squared. Right?
This is
No.
C.
Never mind. Take it back.
You're on the right track. You just swapped with your letters.
Oh.
This is C.
Yeah. So it's 10 squared equals 7 squared plus 6.
Yep. So then I would have, I'm going to move this 7 squared over, but like I'm going to write it as 49 when I move it. So a squared is equal to 100 minus 49. So I just went ahead and squared both of those things. So that then is a is the square root of 51. Again, I'm just kind of combining 2 steps here. Can 51 be broken down? Nope. Now, obviously this value produced a positive number, but pay attention to where it is on here. Is this supposed to be positive or negative? Negative. So, setting them up, obviously sine was given to me. So what would cosine of theta be?
Square root of 51 over 10.
Yep, adjacent over hypotenuse, negative square root of 51 over 10. Tangent.
Negative square root of 51 over 7.
Nope.
Oh, it's not. Negative 7. Negative 51 squared.
And since they're both negative, I'm just going to take the negatives away. What does this have to become, though?
It'd be 7 square root 51 over 51.
Yep. Cosecant. Yep, negative 10 over 7. Secant.
10 square root 51 over 51.
Yep, and cotangent.
Square root 51 over 7.
Yep. So the only real difference is the initial setup of this, but everything else like that you do after that is the same as the problems that we did in a previous chapter. 8. Secant of theta is equal to negative 9 over 4. And then we have that it's from pi over 2 less than theta less than pi. So where does that tell me that this is going to fall?
Quadrant 2.
Yep, quadrant 2. So it's going to be up here. Now, obviously this one they've given us secant instead of sine, cosine, or tangent. That's like, not that we can't think about secant, but it's easier. It might be beneficial on a problem like this to go ahead and set everything up and say, okay, well, secant of theta is negative 9 over 4, so what does that mean about cosine?
Negative 4 over 9.
Yep, negative 4 over 9. So, again, not that we can't think about secant, but I have a feeling you're more inclined to put the things on the right spot on the triangle if you use sine, cosine, or tangent. So, I have that set up there. So, that means that this is adjacent over hypotenuse. So, I have negative 4 here, and 9 here on the hypotenuse. So, then how do I find the other side?
That would be square root of 65, but it would be negative 4 squared plus 9 squared equals. It's the other way around. You know, I can't think right now. It's that.
So then b squared is equal to, I'm going to write this as 81 minus 16. So then b is the square root of 65. Can that be broken down?
No. Doesn't
think
be
so.
5 and 32.
So then, and then is it right that it's positive?
Yeah.
Yep, it's going up. Yep. So now sine of theta,
Oh.
Square root of 65 over 9.
tangent of theta,
Square root of 65 over negative 4.
cosecant,
9 square root of 65 over 65.
and then obviously they gave us secant cotangent.
Negative 4 square root of 65 over 65.
Yep. Any questions about those? Ring a bell. All right, now we're going to get into the new stuff. So this is where you're going to want to have your notes handy. Possibly, well, I have to find the right sheet for y'all. But what you're going to see, well, I'll put it up here so you can actually see it. So I have this cheat sheet here is what this is. This is the pre-cal one because they have more stuff on there than you do. The stuff that's in like the green should be what you have. The stuff that's also in the like maroon is theirs. But basically you have these reciprocal identities, your tangent, cotangent, your Pythagorean cofunction. Did y'all have negative angle identities? I think you did. Okay. In pre-cal, they're going to be called odd and even identities if you want to like make a note of that just so that you're used to it for next year because you're going to want to keep these in your brain. And then eventually we'll have sum and difference formulas and then double and half angle formulas. So what's going to happen is the day before the quiz, most likely, so possibly, probably the earliest Tuesday, I'm going to give you a blank copy of this. And basically you're going to fill this out as part of your grade for your quiz. And then I'll check it, and then you'll have it to use so that as you do these problems that we're doing, you know that you have the right information. So you don't just have to have it all memorized. That's why I'm probably going to do it the day before. Okay? So, and it depends. I'm going to tell you it's for a grade. It might end up being extra credit. You never know. But you're going to want to have those handy so that we can get used to using them. These are problems where the more you do, the easier it gets, okay? If you just do 2 or 3 problems, you're probably not going to understand the concept as well as if you go through and you do like 5 to 10. So we're going to be doing a lot, and then y'all probably have a lot more for homework than normal. Depending on when we finish, I may also give time on Monday to work as well. We'll just see where we're at. So number 10, they say to simplify the expression. So I have sine of x times cotangent of x. So that might look pretty simple, but I want to get this down if possible to like one individual trig function. Now, it doesn't always work out that way. Some of them are not as pretty, but we're going to go with this one. So I'm looking at different ways that I can rewrite things. Well, sine is pretty much just sine, but cotangent can be rewritten using my tangent and cotangent identities as cosine over sine. So I'm going to bring this down. So sine of x times cosine x over sine x. Now sine x's cancel, so this is equal to cosine of x. And then you would be done. 12. Cosecant of theta times the sine of theta plus cotangent squared of theta. So just to kind of, I do my best to try to explain my process because these problems can be really confusing. So anytime I see a trig function being squared, I'm going to think Pythagorean identities. That's always going to be my first thought. But those are all one of the functions squared and then like plus 1, minus 1, something like that. So right away, I don't see that I have that, but I'm going to look and see if there's anything else I can rewrite. So my next thing is, well, the only thing here other than that I can rewrite is cosecant. How can I rewrite cosecant? Should be 1. Yep, 1 over sine theta. And because this came up yesterday in pre-cal when we were doing stuff like this, if you want to change like the thetas to x's, or if they give you other letters and you want them to be x's, you want them to be thetas, that's fine as long as like you're consistent through the problem. Like don't just keep changing them back and forth. And then plus cotangent squared of theta. So that means that the signs cancel. So I now have 1 plus cotangent squared of theta. So then I'm going to look at that point, my Pythagorean identities and say, well, is this one of them?
Cosecant squared of theta.
Yep, 1 plus cotangent squared is cosecant squared of theta. And then you'd be done with that one.
This isn't that bad, but I feel like when we have more stuff, it's going to get difficult.
Toward like number 20, they get a little dicey.
Great.
And what you're also going to notice is that if you come in, like, let's say on Monday, and you ask me to work a problem, there are sometimes different ways to work a problem. So I worked one the other day in pre-cal, and I was like, I don't think I like this. So I had to, like, erase it and start over. That's going to happen sometimes because of trying to, like, there's different ways that we can rewrite things, you know, in different situations. And so it can be frustrating. That's why I said the more you do, the easier it gets because you get used to how to use your identities and all of that. So 14, got 1 plus tangent squared of pi over 2 minus x. So I want to, this might have been in your notes, but just in case it wasn't, I just want to talk about something really quick. I'm just going to do it this way. Tangent squared of x, like this, is the same as tangent of x squared. It's not the x that's being squared, it's the whole tangent function that's being squared. So when we look at this one, it probably would be easier to think about this as if it's 1 plus the tangent of pi over 2 minus x squared. Like that. Okay. So, using your identities, what is the tangent of pi over 2 minus x? Cotangent. So we have 1 plus, now I'm going to put the square back in, cotangent squared of theta. Or I guess in this case it's x for my problem. So 1 plus cotangent squared of x, because that whole thing was being squared. So what's 1 plus cotangent squared?
Cosecant squared.
Yep, cosecant squared.
Theta. X.
My problem is x, but yes. Like you'll notice my whole thing over here has theta, so I have to watch myself when I'm doing the problems if it's like an x that I like don't write the wrong thing. But if you do, like I said, I don't get that picky about it. As long as you're not going back and forth between thetas and x's like in the middle of the problem, I don't care. 16. And I'll tell you, in most cases on the test, it's going to be x because it's a whole lot easier for me to write an x in my program than it is for me to write a theta. So, 16, cosine of pi over 2 minus theta over cosecant of theta, all plus cosine squared of theta.
Oh.
So, cosine of pi over 2 minus theta is what? Sine of theta. Now, to save a step of writing, I'm going to also consider how can I rewrite cosecant?
1 over sine of theta.
1 over sine of theta.
So sine theta times sine theta.
Yep, so when we keep change flip, we have sine theta times sine theta. So we have sine squared theta plus cosine squared theta, which is, should be your very first Pythagorean identity. 1.
Oh, it is.
So was it in your notes where I like explained how to use this one to find the other two?
Yeah.
Okay. Because that can be really helpful because I'm going to be honest with you, the only one that I know off the top of my head is this one. But if I need to find the other ones, I use this dividing by sine squared or by cosine squared to find the other one. Okay. So as long as you know how to divide, if you're doing your stuff and you're memorizing, you can kind of just memorize this one and then find the other ones. 18. Cosine squared of x over cotangent squared of x. Oh, that's it.
I don't like how I wrote that.
So, what here can be rewritten?
That's just good hand. I'm sorry.
I keep writing my S's
The
and Z's.
cotangent could be 1 over tan x.
So it could be, so that's one way I could do it, but is that going to help me cancel anything? No. So whenever I see like a sine and a cosine in a problem and I have a tangent or a cotangent, my first thought's always going to be to rewrite them in terms of sine and cosine. So how can I rewrite cotangent in terms of sine and cosine?
Cosine theta over sine.
Yep, so on top here I'm going to have my cosine squared of x and then all over, and you'll notice I usually do like a ginormous, like when I'm doing a fraction and a fraction, I usually do like a ginormous fraction bar to show like what's actually like the top and the bottom. So then this would be cosine squared x over sine squared x on the bottom. I'm dividing by a fraction, so we keep change flip. So I end up with cosine squared of x times sine squared x over cosine squared x. Cosines cancel, and I'm left with sine squared of x. Are these making sense so far?
Is there ever going to be a number instead of like x or theta?
No, because that would just be a value. I mean, other than like, depending on what you're asking, other than like this,
No, just like
123. Like the cosine of 123? No.
Okay, great.
Because he would just solve.
Yeah.
Oh, yeah. Guess that makes sense.
20. And like I said, I think overall I think these problems are much easier than the ones in the pre-cal book. But because it's the first time you're seeing it, it can be confusing. But next year you're probably going to wish you had these ones instead.
Dicey problem.
All right, cosecant squared of x minus cotangent squared of x all over
Oh,
sine of minus x times the cotangent of x.
I like the way you laughed. It sounds evil.
It's really only like a 3-step problem, but it just looks scary.
Yeah.
All right, so again, trying to walk you through my process. So I see on top, oh wait, this is supposed to be squared. Hold please. Did I copy that right? This is supposed to be squared. There we go. Okay. So I see that I have two things being squared, subtracted from each other. So that makes me think, let me look at my identities. Well, I see that the one that involves these two is 1 plus cotangent squared theta is equal to cosecant squared theta, or obviously x. So to get it to look like this, I would need to subtract the cotangent. So 1 is equal to cosecant squared theta minus cotangent squared theta. So that means that the top is just 1.
Wow.
So then I'm going to go down here and say, okay, the sign of negative x is equal to minus the sign of x. And then I'm going to think, okay, can I do something with cotangent? So again, I see a sign, so my process is to think, okay, can I write this in terms of sine and cosine? And so it would be what?
Cosine.
Cosine over sine. Sines would cancel. So I have negative 1 over the cosine of x. The negative can go top, bottom, wherever. Now, what's 1 over cosine?
1 over cosine.
Secant.
Secant, so this would be minus secant of x.
We're just gonna skip it.
Now, I don't normally do odd ones, but this one's a little odd, so I'm going to do it anyways. I used to assign this one for homework, and I always had to go over it, so I just do it now. Cosine squared, it's running away. What is happening? Cosine squared of x, tangent squared of minus x, minus 1, all over cosine squared of x.
Does it cancel out?
That's a good question. It does not, because it's being subtracted. There's a subtraction here. If that wasn't there, yes, it would just cancel. But because of that, we cannot. So this is where what I mentioned earlier, that the tangent squared of x is equal to the tangent of x squared, is going to be important. Because what is the tangent of minus, in your case, theta?
That is negative tangent there.
Minus the tangent of theta. So this is going to be on top cosine squared of x times negative tangent of x squared. That's important because of the sign. The S-I-G-N, not the S-I-N. So what happens when I square this? What happens to this?
It comes positive.
It becomes positive. So I have cosine squared x times tangent, I don't know why I just wrote that. Tangent squared x minus 1 over cosine squared x. So now I would see if I can rewrite tangent in terms of sine and cosine. So how would I do that?
Sine over. Yeah.
So in this case, because it's squared, it'll be sine squared x over cosine squared x.
That's how y'all are finding that. Wow.
That's why I was like, you're going to want to have, I'll give you a blank copy. I just need to see, I might give it to you today, but I might not be able to give it to you till Monday so that you'd have it to like practice. Because it tells you on here like how many of each there are too, so that you know how many to have. All right, so then my cosines cancel.
Right.
Wait, we have to. Oh. We have to memorize all of that.
Yeah.
That's what I'm telling you now, though. You can work on it this weekend. So now I have sine squared x minus 1 over cosine squared x. Well, do I have a sine squared x minus 1 in my identities?
No.
Not directly, but I do know that sine squared plus cosine squared, I'm not writing the thetas, is equal to 1. So if I was going to subtract this one over here, and I got sine squared minus 1, I'd also have to move this cosine over here. So that would be negative cosine squared.
Oh, and then divide.
So now sine squared x minus 1 is equal to minus cosine squared of x. So I have minus cosine squared of x on top over cosine squared of x. And so then that's equal to negative 1.
Wow.
All that to
for
get
a negative
negative.
1. How fun.
Okay, so the instructions on those was to simplify. The next thing is verify.
Oh, I thought we were.
Yay! Even more difficult.
They could be, but they actually could be easier. So on these ones, we're simplifying to get down to what we hope is the most simplified answer. On verify, they tell us what it's supposed to be equal to. We just have to show that it's equal to that. So on this, I'm going to tell you, leave the right side alone. If you don't, you will get the problem wrong. Don't touch it. So 26. Tangent of theta times the cosecant of theta times the cosine of theta is equal to 1.
So,
So
touch 1.
all of this, when I simplify it, has to be equal to 1. So what I like to do is I like to draw a little arrow here so that I don't touch it. I'm not tempted to write over top of my arrow. And then on the left side, I'm going to do what we've been doing for the last 8 problems or however many it was. So how can I rewrite tangent in terms of sine and cosine? Because I see I have a cosine, so that's probably going to be the route I want to go.
Yeah.
Sine theta over cosine theta. What about cosecant? 1 over sine theta. And then obviously cosine theta is just there. So sines cancel, cosines cancel.
Oh.
It's 1.
1 equals 1, and then we put in a little check mark
Oh.
that we verified it.
That's so cool. I made my arrow way too long.
Sometimes I do that too. Sometimes I make it too short and it's like 10 steps and I like took 2 and I'm like, oh, whoops. 28. Sine of pi over 2 minus x times the tangent of x is equal to the sine of x.
So don't touch the other side.
Right. All right. How can I rewrite sine of pi over 2 minus x?
Yeah.
So cosine x. How can I rewrite tangent?
Sine x over cosine x.
Sine over cosine.
Cosines cancel out, so you have sine x.
Cosines cancel. Sine equals sine.
Ah! Oh my gosh.
Now, obviously, you have the starting point and you know what the ending point is supposed to be. So I have had people on tests before think, oh, well, as long as I write that sine x equals sine of x, she's going to mark it right.
No, there's no way.
I'm going to go through and I'm going to look and make sure your work makes sense. But that's where I tell you that yours might not look like mine, and that's okay as long as what you've done makes sense to get to the final answer. Okay? So these are ones where, regardless of what your final answer is, I am looking at the work that goes with it. So 30, we've got 2 minus the cosine squared of theta is equal to 1 plus sine squared of theta.
Oh, wait.
I keep forgetting letters.
So we still don't touch the 1.
Yep. We don't touch
Never
it.
touch it.
I made that way too long. All right. Now, I might blow your mind with this one.
Oh.
1 plus 1 equals 2.
Oh.
Oh.
Minus cosine squared of theta. Why might I have done that? Is 2 minus cosine squared of theta one of my identities? But is 1 minus cosine squared of theta?
Yeah.
Yeah.
What's 1 minus cosine squared of theta?
Sine.
Yep. So I have 1 plus sine squared of theta equals, 1 plus sine squared of theta. I made my arrow too long this time.
Me too.
Oh wow.
So I know that's something crazy, but you can divide up a number by adding it together. And that might be what you have to do on them.
Like 6.
It's under negative angle identities.
32. Sine squared of minus x over tangent squared of x is equal to cosine squared of x. So what is the sine of minus x?
Negative sign.
Negative sine x. But that's all squared. I did draw my arrow. So what happens to this over here?
Becomes positive.
It's going to be positive, so I have sine squared of x over, I can rewrite tangent as
Sine. Yeah.
Sine.
sine squared over cosine squared. Keep, change, flip, and I get what?
Cosine squared.
Yep.
Cosine squared of x equals cosine squared of x. And I'm done.
Seems crazy.
You say that every single lesson. This seems
You think that's too simple?
No, please no.
She got really hard.
This is our last one.
Oh, Jonah, you suck.
We were doing this one either way. I just thought it was ironic. All right, sine of x over 1 minus cosine of negative x is equal to the cosecant of x plus the cotangent of x. Now, I will
What?
tell you, you need a relatively long arrow on this one.
great.
Well, Brie, I don't have that much left on my paper.
1, 2, 3, 4, 5, 6 lines probably. If you write your fractions in one line.
That's exactly
Thank
how
goodness
much
I
I
just
did.
flipped my page.
I do write my fractions in one line.
Okay, then you should have room. Okay, so on top I have sine of x. There's nothing I can really do to rewrite that at this point, so I'm going to keep that. Now, what about the bottom here?
You can make that into cosine. Wait, it's already
The cosine of minus x is what?
cosine.
Is just cosine, but that means it was already minus, so it just stays that way. So 1 minus the cosine of x. Now, any idea? Because obviously, see, this is why if I was simplifying, I'd probably leave it there because I wouldn't know I needed to go farther. But with verifying, they've told me how far I need to go. So I know I'm not done. Anybody have any ideas what I might be able to do?
Wait,
Do you remember when we did conjugates?
Who?
Conjugates?
What is a conjugate?
Like plus or minus.
oh.
Like minus I and positive I.
Yeah.
Those are technically complex conjugates. So I see that this is 1 minus, so I'm going to do 1 plus. So 1 plus cosine x, top and bottom. Multiplying. Now, what I would tell you is I would not multiply the sine of x by the 1 plus cosine of x. Like, I wouldn't go ahead and distribute it. I would leave it as two separate things for right now. Sometimes I have to go through and I have to redo it, but not always. So, on the bottom, this is going to be a difference of squares. So this would be 1 minus cosine squared of x. Okay, because if I FOILed, I have 1 times 1 is 1. 1 times negative cosine, so that's minus cosine. 1 times positive cosine, that's plus cosine. Those things would have canceled. And then cosine and cosine are cosine squared. So this becomes 1 minus cosine squared.
Excuse me.
Yeah.
That was a lot.
So now on top, I have sine of x times 1 plus cosine of x over, what's 1 minus cosine squared of x? a manipulation of an identity.
Oh, it's the.
Sine squared plus cosine squared equals 1, so 1 minus cosine squared equals.
Wait, sines?
Subtract cosine from 1, and what are you left
Cosine
with?
squared.
Sine squared.
Oh, where is this now?
Oh, I thought I was wrong.
It's using the proving.
Oh.
Now, this is why I'm going to hit back to Addie's question that she had earlier. In this case, can I cancel my signs?
Yes.
Yes, because it's being multiplied. This is why I did not multiply this through. This sign cancels with the squared part. I still have a sign on the bottom.
Oh no, my shoe came off.
So I have 1 plus cosine of x over sine of x right now.
Goodness gracious.
Now, I can split these things because that would be a common denominator. If this was flipped upside down, I couldn't do this, but this direction, this is 1 over sine of x plus cosine of x over sine of x. What's 1 over sine of x?
Cosecant.
So cosecant of x plus cosine over sine.
Cotangent.
Cotangent of x is equal to cosecant of x plus cotangent of x. And I'm done.
Oh my goodness.
Wow.
I was-
Now, that's the hardest one in here. Well, maybe besides 33.
Which
Oh.
is good.
Please, that's gonna be our homework, bro. You'll be like,
Very.
All right, homework problems.
Under the verify, is there ever going to be one that isn't equal to the other thing where you just say no?
I mean, it could be, but I've never seen one in any of our books do that.
do what?
Like
Where
it doesn't.
Like it's impossible to equal what it says.
5, 7, and then 11 through 19 odd, and then 25 through 33 odd. So we don't have a ton of time left, so excuse me, I'm gonna let y'all have some time on Monday to work as well if we're not done.
Yeah,
But go ahead and have your notes for the next section ready for Monday because we might start the next section on Monday. Oh, actually, I don't know if there were notes for the next section. Okay, well then never mind. Don't worry about that. I was like thinking about it because this stuff is 2 separate sections in the pre-cal book, but it's obviously one in here. We'll be solving equations if we start that on Monday.
Yep, we're doing
So
33.
you just like write the title and then
Pretty much.